So here is one more conceptual problem, a beautiful one on collision. Three balls, masses are identical, ma equals mb equals mc, are placed on a smooth horizontal surface. B collides with C with an initial velocity v as shown. The total number of collisions between the balls will be, and he has assured you that all the collisions are going to be perfectly elastic. So this helps you recollect one very important concept or statement, you can say, that is, whenever two identical masses will have a collision which is perfectly elastic and the collision is head on. See, I am referring to three important conditions to be satisfied. One is the collision should happen between identical masses, second is the collision has to be head on, and the third is the collision has to be perfectly elastic. So if all these three things are assured, then the momenta are going to be exchanged. So initially one body was moving with velocity v, immediately after the collision that body will come to rest and the other body picks up the same momentum, or you can say starts moving with the same velocity. So if you allow B to move with a velocity v and collide with C, B will immediately come to rest after the collision and C will continue its journey ahead. Therefore, if C moves ahead and B stops there, there is no more collision going to happen between the balls that you have selected. So how many collisions have happened then? Only one, and that is between B and C, which you have started. So answer is 1. So here is a simple problem which reminds you about the graph of force versus time, and I hope you remember that the area under the force versus time, which is Ft, will always give you the change in the momentum that the particle has suffered. So let us read the problem. A 2 kg toy car moves along the x-axis. The car starts from rest at t equal to 0 and the force versus time diagram is given to you. The velocity of the car is to be found at t equal to 10 seconds, right? So the force which has acted on the particle for this time interval of 10 seconds is continuously changing. Here the force is increasing, here it has decreased, here the force direction has changed, then it has remained constant for some time. So the force has been continuously changing, and therefore had you thought of solving the problem with, say, s equal to ut plus half t square or v equal to u plus at, you would have gone wrong, because those equations are to be used only when the acceleration is constant, and here when the force is not constant, the acceleration is not going to be constant. So please remember that if it is a force time diagram, area under the diagram will directly give you the change in the momentum, and momentum is mass into velocity, change is final minus initial. Fine, and initially the car has started from rest, so there is no initial momentum. So whatever you get as the area under the force time diagram is going to be the final momentum, and mass into velocity, mass is given, so velocity can be found. Fine, so let me just calculate the area. So this triangle has got an area of half base into height, so it is half, base is 8 and height is 4, right? And because that area is above the time axis, I have taken it as positive, and now this area is below the time axis, out of which I am required to take only this triangle and this rectangle. So triangle area is again minus half, base is only 1 and height is 2. I am talking about this triangular area here, and then rectangle amounts to minus length into breadth, that is 1 into breadth is 2. So the total area enclosed in the force time diagram till 10 seconds is 16, right, minus 1 minus 2, and that is 16 minus 3, which is 13, and remember positive. So this 13 is 13 Newton second, is nothing but the change in the momentum that the particle has suffered. Got it? Okay. So now 13 is also one of the options there, plus please don't select that particular option, because he has not asked you the change in the momentum or the impulse, he has asked you the velocity. So I will write this 13 as mass into velocity. Mass is 2 kg, velocity is what I want to find out, and that should be equal to 13. So V is equal to 6.5, and because 13 is positive, velocity is also positive. So the right answer is 6.5 in the direction of positive x-axis, meters per second. Got this? I hope you enjoyed this simple problem. Remember, force versus time diagram, and area always gives you the change in the momentum or the impulse. So here is a very simple problem on collision. Let us read the problem first. A 2.5 kg mass moving with 15 meters per second collides with a 5 kg body initially at rest. They stick together after the collision. So find their velocity after the collision is the question. Had the two masses been identical and the collision been perfectly elastic, then I think the momenta would have got exchanged, and we would have directly declared that this body which was initially moving will come to rest and the other one will pick up the same velocity. But here the masses are different, and moreover the collision is not at all elastic because they are going to stick together. So the collision happens to be perfectly inelastic. Coefficient of restitution happens to be 0 in this case. So we will just conserve the momentum and try to write the final velocity that the particles are going to pick up. So it's like this. See, initial momentum is 2.5, the mass of that particle moving with a velocity of 15, and that happens to be 37.5. I didn't take the momentum of the second particle, you must have noticed it there, because the second particle was initially at rest. So it didn't have any velocity, so there was absolutely no momentum associated with that particle. Only this was moving. So I have written the initial momentum only of one single particle. And then he says they stick together after the collision. So while writing the final momentum, I am supposed to write the mass as 2.5 plus 5, which is going to be 7.5. So 7.5 becomes the combined mass of the two bodies which have stuck together. And now we don't know what is the velocity with which they are going to move. So let us call that velocity as v. So we have written the initial momentum, we have written the final momentum, and because the two particles have collided among themselves, the force that they must have exerted on each other is totally internal. And the statement says, in the absence of an external force, the momentum can be conserved. So we are going to conserve the momentum. I will say initial momentum is equal to the final momentum and solve the problem. So 37.5 is equal to 7.5 into v, and that gives you the value of v as 5 meters per second. So v is 5 meters per second, and that makes your option B as perfectly correct. So I hope you understood this. It's a very simple problem. Two bodies were there, one body was moving, it just got collided with one more which was initially at rest. They stuck together and they started moving as a common mass, and the velocity was 5. So here is one more very basic or a very simple problem. So let us read it and try to understand. The motion of the center of mass depends on total external forces, total internal forces, both A and B, neither A nor B. See, this is a very bold statement of conservation of momentum and center of mass, which says that it is only in the absence of an external force the momentum can be conserved. So, which means if initially the center of mass was at rest, it is going to remain permanently at rest, or if it was already moving with some velocity in a particular direction, it will continue to move with the same velocity in the same direction. But this is only when there are no external forces, and that is when you can really conserve the momentum. So he says the motion of the center of mass means the center of mass is still not moving, and if at all the center of mass has to move, is it because of the internal forces or external forces? So, the answer is it is just because of the external forces, because internal forces cannot make the center of mass move. Internal forces can do the work, internal forces can change the kinetic energy, but because of the internal forces, the center of mass is not going to be displaced. So, the correct answer here is A. So, here is one more very simple problem. I think you can call it as a continuation of the previous problem also, provided you have understood the previous one. A shell at rest explodes, he says. The center of mass of the fragments moves along a parabolic path, moves along a straight line, moves along an elliptical path and remains at rest. See, what you should understand here is the shell was initially at rest and it has suddenly exploded. So, this explosion is basically because of the internal forces. So, there are absolutely no external forces which were acting on the shell initially because it was at rest. Therefore, the center of mass of that particular shell, or you can say center of mass of all those fragments into which the shell has got exploded, should remain at rest. It need not have to move either in a parabolic path or an elliptical path or a straight line. The shell was initially at rest. Explosion is because of the internal forces, and we told you in the previous problem that it is just the external forces which can displace the center of mass. So, the shell was initially at rest and the fragments, the center of mass, should still continue to remain at rest. So, the correct option here is D.